get to it. Number one, we know that the first thing we need to do is write down our givens, get our points. So measure angle ABD is equal to measure angle CBE. That's a given. And what is that actually telling me? That's telling me that this angle ABD is equal to the measure of CBE, which is this one right here. So they look the same. I also know that there's some overlap in between that will come into play later. And where am I headed? What I need to prove. So I'm gonna write that at the bottom. Get my points, A, B, C. But it is important to know where we're going. And so if I look at it on here, ABC is this little one right here, and DBE is this one here. So that makes sense. You got some overlap here, and if you get rid of those, you got the little two pieces. So that's where we're headed. All right, well, I've got angle ABD. I got the measure of angle ABD, and I need to say something about it. Or what I should say is, if I didn't know what to write down right there, I got to figure out what else to do. And I don't have any other information, so I've got to look at my picture. And the one thing that I can do when I look at my diagram, my picture, my visual here, is that I know that I have two angles equaling the bigger angle. So I can use angle addition postulate. So I'm going to take ABC plus CBD equals that whole big angle right here. So ABD equals ABC, measure angle ABC, plus the measure angle CBD. So that's that overlap right there. Measure angle CBD. And what allows me to do that? The angle addition postulate. So that tells me this first part. Now this second angle here, CBE, is a mixture of two parts also. That angle CBD and DBE. So I'm going to do the same thing, use angle addition postulate to write measure angle CBE. So measure of angle CBE equals CBD. So the measure of angle CBD plus the small one right there. So the measure of angle DBE. So measure of angle ABD right there equals this. Measure of angle ABC plus measure of angle CBD. And that equals the measure angle CBE and the measure angle CBE. We've just figured out what that is using angle addition postulate. So that's the measure angle CBD plus measure angle DBE. So I substituted those both back into the original equation, and that is substitution property. And I realized, that I did not write angle addition postulate for the one above. So let me do that and get my points. Angle addition postulate. And lastly, how do I go from step 4 to step 5? Measure angle ABC, measure angle DBE. There's measure angle ABC. There's the measure angle DBE. Measure angle CBD is here. Measure angle CBD is here. Oh, okay. So if I subtract the measure angle CBD from the left, that'll cancel out. But that means I have to subtract it from the right. That means that would cancel out, and then that would leave me with those two parts. So that works. Subtraction property. All right. So there's number 1. All right, now let's look at number 2. I'm going to write down my givens first. So the ray DB bisects angle ABC. That's given. It's the first one. Then angle 2 is congruent to angle 3. That's my second one. That's given. I need to know where I'm going. Measure angle 1 equals measure of angle 3. It's that one. All right, so what do I have going on here? So my first given, what does that tell me? DB bisects ABC. So that means it cuts this big angle in half. If it cuts it in half, this angle is the same as this one. So that's what I'm going to write. Angle 1 is congruent to angle 2. My first step led to my third step. Because DB bisected it, it cut it in half. And that is the definition of angle bisector. That's how I know that. All right, next step, we've got angle 2 is congruent to angle 3. Angle 1 is congruent to angle 2. I notice I have angle 2 in both of those. So if I know angle 3 is congruent to angle 2 and 2 is congruent to angle 1, that means that these two must be congruent to each other. So sure enough, I've got angle 1 is congruent to angle 3. So what allows me to go from one thing to a second thing to a third thing and then skip to the first and the third? That is transitive property. And the final step here, I'm going from congruence to equals. What allows me to go to congruence from equals? That is the definition of congruence. All right, there's my first two proofs. So check those, see how many you got right, see how many steps you got so that you can self-evaluate. Then we're going to do the back. So let me write down my givens. First one, angle 1, angle 3 are complementary. Given. Then angle 1, angle 4 are complementary. Given. Just to remind myself, complementary means that they add up to 90 degrees, just so I don't forget. Let me write down what I need to prove so I know where I'm going. Angle 3 is congruent to angle 4. So from the very beginning, I need to figure out what I need to do. I've written down my two givens. What do those tell us? Well, angle 1 and angle 3 are complementary. So that tells me that the measure of angle 1 plus the measure of angle 3 equals 90 degrees. I know that because that is the definition of complementary. Two angles that add up to 90 are considered and called complementary. I did that for the first given, and guess what? I can do the same thing for the second given, but I'm using these angles. So angle 1 and angle 4 are complementary. Therefore, measure of angle 1 plus measure of angle 4 equals 90 degrees. Same definition, same reason. All right. Now I have to figure out what's next. I've got these two steps. Now, measure angle 1 plus measure angle 3 equals 90. Measure angle 1 plus measure angle 4 equals 90. They both equal 90, so that means they must be equal to each other. All right, so if I plug that in for there, measure angle 1 plus measure of angle 3 equals 90. Don't write that just yet, because I'm trying to show that for step 4, that's also equal to 90. And 90 equals measure angle 1 plus measure angle 4. But I don't need to write that 90 in the middle. So I just write measure angle 1 plus measure angle 3 equals measure angle 1 plus measure angle 4. I substitute those in, so that is substitution property. And much like on the first page, I'm going to use a similar tactic here. Measure angle 1 plus measure angle 3 equals measure angle 1 plus measure angle 4. I notice I have measure angle 1 in both, so if I subtract it from the left side and subtract from the right side, they both cancel out, and I'm left with measure of angle 3 equals measure of angle 4. And I subtracted them from both sides, so that's my reason for why I'm allowed to do that. Subtraction property. Then lastly, one of our most common properties that we use, switching from equals to congruence. That is the definition of congruence. All right, proof number 4. Proof number 5. Looks very similar because it is. Angle 2 and angle 3 are supplementary. That means they add up to 180. So let me write these two down. Angle 2, angle 3 are supplementary. That's given. Angle 3 and angle 4 are supplementary. That's given. Let me write down where we need to go. So that's angle 2 is congruent to angle 3. Or sorry, angle 4. Sorry, angle 2 is congruent to angle 4. I don't know how the reason for that is. I got to work my way down. So what did each given tell us? What does angle 2 and angle 3 being supplementary tell me? That tells me, because I know the definition of supplementary, that they add up to 180. So measure angle 2 plus measure of angle 3 equals 180. That is the definition of supplementary. And the second given tells me very much the same. Measure of angle 3 plus measure of angle 4 equals 180. If you notice, that is very much the same as what we did in the proof before, except we used complementary and that they added up to 90 degrees instead. Very similar type of proof. All right, and then much like the one above, this equals 180, this equals 180, so I can set those equal to each other or substitute them in. So measure of angle 2 plus measure of angle 3 equals 180. 180 is also equal to the measure of angle 3 plus the measure of angle 4 due to substitution, because I plugged those into each other. Now that allows me to look and see what's next, which is measure angle 2 plus measure angle 3 equals measure angle 3 plus measure angle 4. There's a measure angle 3 in both, so if I subtract it from the left and subtract it from the right, I'm left with measure of angle 2 equals measure of angle 4. I subtract them from both sides, so that's how I ended up here. Now to get to the next step, or the last step, I've got equals to congruence. Anytime I switch from equals to congruence, so angle 2, angle 2, angle 4, angle 4, the measures are gone, the equals gone, switching to congruence. That is the definition of congruence. So what you should see is that these two proofs are very, very, very similar. This has complementary and they add up to 90. These are supplementary and they add up to 180. Last proof. Okay, angle 1 and angle 2 are complementary. That's given. And then where am I headed? Angle 2 and angle 3 are complementary. So what do we know? Angle 1 and 2 are complementary. So if I look over here, sure, angle 1, angle 2, they add up to 90. I even have the 90 right there. So what do I know from this? Much like above, measure of angle 1 plus measure of angle 2 equals 90 degrees, because that is the definition of complementary. Then I got to figure out what I'm doing next. There's nothing really obvious right away. So that means, and I don't have another given, so that means I need to go look at my picture. So what's going on with my picture? I've got 1 and 2 next to each other. I've got 2 and 3 across from each other. So let me look. I need to end up with 2 and 3 are complementary. So I definitely need to connect 2 and 3 together somehow. So what's the connection between 2 and 3 here? Let's see. All right, first off, there's definitely a typo on this. This should not be angle 2. That should be angle 1. So correct that. Now we can end up in the right direction. Why? Because I noticed that angle 2 and 3, they're not complementary. They're right across from each other. That means this angle and this angle are the same because those are vertical angles. So that's what I know next. Angle 2, angle 3 are vertical angles because I know that. So I can look at them and tell. But why do I know? Because I know what the definition of vertical angles is. So there we go. Definition of vertical angles. And if those are vertical angles, what do I know about vertical angles? Vertical angles, I know that they're congruent. So angle 2 is congruent to angle 3 because the vertical angles theorem tells me that is true. All right, what's next? Well, I got up above, I had measure angle 1 plus measure angle 2 equals 90 and got stuck there. Then I went to vertical angles, said they were congruent. So how can I connect step 2 and 4? That's got an equal sign, that's got a congruent sign. So I'm going to switch this to equals. So switch congruence to equals measure of angle 2 equals measure of angle 3. We did that above with the definition of congruence. Now that they're both having equals, I could put those together somehow. Well, if I look at measure angle 1 plus measure angle 2 equals 90, then I have the measure angle 2 equals measure angle 3. So they both have a measure angle 2, so I can just plug in measure angle 3 right there. So I've got measure angle 1 plus this new thing that's plugged in, measure angle 3, equals 90. I plugged it in, so you should be thinking substitution. And the very last step should be somewhat predictable because that's what we did in number 1 and number 2. If they're complementary, then they add up to 90. Down here, they add up to 90, then they're complementary. That is just the definition of complementary. And we're done, and we're ready for our quiz. Check your answers with these. Go back to the front, check and evaluate yourself, and then you'll know if you're ready. All right, let's go.